Hello everyone, welcome back to the channel. If you are preparing for the CSCA exam, this series will help you. In previous lectures, we have already covered the 30 questions, and in today's video, we will cover the last 17 questions that are asked in December 2025 physics paper. So let's start it. Question number 31. When a light ray hits a glass air interface at an angle of incidence 30 degree, the angle between reflected and incident ray is. According to law of reflection, we know that angle of incidence equal to angle of reflection. So here angle of incidence is given as 30 degree. So angle of incidence will be equal to angle of reflection. So angle of reflection will also become 30 degree. In the diagram, theta, that is the total angle between incidence plus angle of reflection, that will be equal to 30 plus 30, that is the 60 degree. So option B is correct. Question number 32. An ideal gas of certain mass undergo an isobaric process where pressure is kept constant from state A to state B. Suppose that at state A the volume is V1 is equal to 1.5 meter cube and the temperature T1 is equal to 300 Kelvin. At state B the temperature is T2 is equal to 400 Kelvin. The volume at state B is equal to. So V1 is equal to 1.5 meter cube and T1 is given as 300 Kelvin. T2 is equal to 400 Kelvin and we have to calculate the volume V2. So according to ideal gas equation, PV is equal to nRT, where P is pressure, V is volume, N is number of moles, R is gas constant and T is temperature. So according to question, pressure is constant. So V is equal to nR divided by P into T, where nR by P will become constant. So V is equal to K times T. So volume will directly proportional to temperature. So accordingly we can write V2 by V1 is equal to T2 by T1. So V2 is equal to T2 divided by T1 into V1. We will put the value of T2 by T1 into V1. T2 is equal to 400 and T1 is equal to 300 into V1 is equal to 1.5. Then when we calculate this value, we will get 2 meter cube. So option D is correct. Now we will move to next question, that is question number 33. As shown in figure, there is an electric field in space with 2 points A and B. Which of the following statement is correct? So option A is the electric field strength at point B is greater than at point A. The electric field strength at point A is greater than that at point B. The electric field is uniform electric field. D. The electric field strength at point A and B is same. So we know that the electric field are stronger where they are crowded and the electric fields are weaker where they are far from each other. So point A is the field of strong and the B point is representing the weaker field. So option B is correct. That is the electric field strength at point A is greater than that at point B. Question number 34. A child with a mass is equal to 20 kg with the speed v is equal to 6 meter per second jumps onto a stationary cart on a smooth horizontal surface. Given that mass of cart is capital M is equal to 40 kg and their final common velocity is, so mass of child, that is small m, is equal to 20 kg and its velocity v is given as 6 meter per second. Capital M, that is the mass of cart, which is 40 kg, and we have to find the combined velocity. So according to conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So m into v plus m into u2, that is the initial velocity of cart is 0, so is equal to final momentum, that is m into v V, capital V is combined velocity plus m into capital V. So when we substitute all these value, we will get 20 into 6 is equal to 40 plus 20 into capital V. So V is equal to 20 into 60 divided by 60. So this 6 get cancelled and we will get velocity V is equal to 2 meter per second. So option C is correct. Question number 35. A 0.2 meter wire carrying a constant current I is placed in a uniform magnetic field with B is equal to zero point 0.8 Tesla if the maximum ampere force is F is equal to 0.08 Newton. The current is, here the length of wire is given as 0.2 meter and magnetic field is zero point 0.8 Tesla. Maximum force experienced by wire is 0.08 and we have to find the current. So we know that force is equal to ILB sine theta. For calculating the maximum force, so theta will be 90 degree and we will put the value of maximum force, that is 0.08, and I into L is equal to zero point 0.2 into B is 0.8 into sine 90 is 1. So I will be equal to 0.08 divided by zero point 0.2 into zero point 0.8. So after solving this, we will get 0.5 ampere. So option A is correct. Question number 36. A basketball of mass 0.5 kg bounces from ground to height of 1 meter and returns to ground. The total change in gravitational potential energy. Since ball is moving from initial point I and then it moves to final point F and these points are the same. So initial gravitational potential is mgh where height of ball is 0. So initial potential energy will also be 0 and final potential energy is also 0 because here the height is also h. So the difference of gravitational potential energy is 0. So option A is correct. Question number 37. Two equal but opposite charges A and B, each with the magnitude of charge q is equal to plus minus 3 into 10 raised to power minus 29 coulomb, are fixed r is equal to 3 centimeter apart in vacuum. Given that electrostatic constant k is equal to 9 into 10 raised to power 9 Newton meter square per coulomb square, the electric field strength at midpoint A and B. Here two charges are given, that is plus q and minus q, and both are having the same magnitude and these are separated by a distance of 6 meters. So we need to convert 6 centimeter into meter, that is 0.06 meter. So the net electric field at midpoint, that is the point C, will be the net electric field due to point A and net electric field due to point B, and these two electric field are in same direction, so net electric field get added. So EA will be K into Q divided by R by 2 whole square plus KQ divided by R by 2 whole square, and when we calculate this we will get 4 times K into Q divided by R square plus 4 times K into Q divided by R square. So the total will become 8kq divided by r square, and we will put the value of k, that is 9 into 10 raised to power 9, and q is equal to 3 into 10 raised to power 29, and r is equal to 6 into 10 raised to power minus 2 whole square. And when we calculate this value we will get 6 into 10 raised to power minus 16 Newton per coulomb. So option D is correct. Question number 38. A ball is thrown horizontally from height h is equal to 20 meter with velocity v naught is equal to 20 meter per second. Ignoring the air resistance and its velocity when it lands is. We have to find the value of velocity at which it reaches to ground. So the height of tower or height is given as 20 meter and initial velocity is 20 meter per second. So we will use third equation of motion, that is v square minus u square is equal to 2as, where acceleration here will be acceleration due to gravity, and in this equation we will put the value of initial velocity which is given as 20 meter per second and h is equal to 20. Then we will get v square is equal to 400 plus 400 and v square is equal to 800, so velocity will be equal to 20 root 2 meter per second. So option C is correct. Question number 29. As shown in figure, if two objects A and B with equal mass are placed on a horizontal disk rotating uniformly around the vertical axis and two objects remain stationary relative to disk, then this disk is moving with the same angular velocity. So angular velocity at point A and point B will be same. And that is the option C is correct, but the linear velocity will not same because it depends upon the distance from the axis of rotation, where this RA is greater than RB, so velocity, that is the linear velocity at point A, will be greater than velocity at point B. So other options, that is option A, B and D, are incorrect. Only option C is correct. Question number 40. When a point charge of 4 into 10 raised to power minus 26 coulomb is moved from a point A to B in an electric field, the electric force does a negative work of 8 into 10 raised to power minus 24 joule. The potential difference between A and B. We know that potential difference is equal to work done by unit positive charge. So we will put the value of work done, that is 8 into 10 raised to power minus 24 divided by Q, which is 4 into 10 raised to power minus 26. After solving this, we will get 200 volt. So option C is correct. Question number 41. A conducting sphere A that can be regarded as a point charge of 8q, a similar sphere B carrying negative charge of minus q has a distance r from A. If two spheres are put in contact and return to original position, their new Coulomb force becomes. So two spheres are given, sphere A and sphere B. Sphere A carries 8q charge and sphere B carries minus 4q charge. So according to Coulomb force, F is equal to K into QA into QB divided by R square. Here QA is equal to 8q and QB is equal to 4q. So force will be equal to K times 8q into 4q divided by R square. And when these two spheres they are put in contact, then there will be redistribution of charges. So this, the charge will become 8q minus 4q divided by 2. This is equal to 2q. So and these two spheres now they are placing to the distance of r. So the Coulomb force will become K into 2q into 2q divided by r square. Then we will take the ratio of f dash divided by f and we will solve this, and it will become f dash is equal to f by 8. So the new force will become 1 by 8 times of the initial force. Question number 42. A bullet traveling horizontally penetrates two identical blocks, slowing from 700 meter per second to 500 meter per second after the first block. Its speed after the second block is. So the initially the bullet is moving with the speed of 700 meter per second. After it collide with block 1, it it penetrates the block 1, its speed becomes 500 meter per second. Then by this velocity it penetrates the block B, and we have to find the velocity at after penetrating the block 2. So here loss in kinetic energy in first block equal to loss in kinetic energy in second block, that is half of m into u1 square minus u2 square is equal to half of m into v1 square minus v2 square. So we will put the value of u1, that is 700 meter per second, and u2, that is 500 meter per second. v1 is equal to 500 meter per second, and when we solve this, 700 square will become 49 into 10 raised to power 4, and 500 square will become 25 into 10 raised to power 4 is equal to 25 into 10 raised to power 4 minus v2 square. So when we solve that, this equation v2 will become 10 raised to power 4, and we will take the square root of v square v, that is then V is equal to 100 meter per second. So option A is correct. Question number 46. An object of mass m is equal to 2 kg is stationary on a smooth horizontal surface. It is then subjected to a horizontal force F. The change of F with time is shown in figure. The kinetic energy of object at time t is equal to 2 seconds. So here the graph is given between force and time. So we know that the impulse is equal to area under the curve ft graph. So when we calculate the area, it will become 4 into 1 plus 6 into 1, that is 10 Newton per second, and this is the impulse. And we know that impulse is also equal to change in momentum. Here the initial velocity of object is given as 0 meter per second. So we will put the value of impulse, that is 10 is equal to m, that is 2 into v minus u. So from this we will get v is equal to 5 meter per second. Then we have to calculate the kinetic energy, and we know that kinetic energy is equal to half mv square. We will put the value of m, that is 2, and v is equal to 5, and when we solve this we will get kinetic energy is equal to 25 joule. So option A is correct. Now we will move to question number 44. As shown in the figure, a horizontal platform AB has a height h of 0.8 meter above the ground. A block slides from point A with a uniform acceleration and initial velocity v0 is 6 meter per second. The coefficient of friction between block and platform is mu is equal to 0.25. The block flies off the edge of the platform horizontally at a point B. If length of AB is 2.2 meter, the horizontal landing distance from the bottom of the platform is, here G is given as 10 meter per second square. So initially the block is at point A, which is moving with the 6 meter per second, covering the distance AB, that is 2.2 meter. Then it will fall from point B and it will cover a distance CD from height h, that is 0.8 meter. So we have to calculate the distance CD. So accordingly we know that acceleration of the block due to friction is equal to friction force divided by mass. Here the friction force will be mu times normal reaction, where normal reaction will becomes mg, and mu mg divided by m. So m get cancelled, and we will put the value of mu, that is 0.25 into 10, that will become minus 2.5 meter per second. This friction force is against the the force in which the object is moving. So that is why here we are getting negative sign. Then we will use the third equation of motion. V square minus u square is equal to 2as, and we will put the initial velocity u is equal to 6 and acceleration due to this friction force, that is minus 2.5, and the distance covered by the block is 2.2 meter. So when we solve this, we get the velocity of block at point B will be equal to 5 meter per second. Then we will find the time of flight, the time for which the block is in air as it moves from point C to D. So the block falls from the height h, and here the horizontal velocity of block will be 5 meter per second, but the vertical velocity is 0. So we will use the second equation of motion, s is equal to ut plus half at square. We will put s, that is 0.8, is equal to initial velocity u is 0 plus half into 10 into t square. So the time for which the block is in the air, that is time is 0 0.4 second. Now we will calculate the distance covered by a block, that is the CD. The horizontal distance will be equal to u times ux into t, where ux is the velocity of particle along x direction, that is 5 into time is 0.4. So after solving this we will get 2 meter. So option B is correct. Ash Now next question, that is question number 25, 45. As shown in figure, the two ends of parallel metal rails placed horizontally are connected with the resistor R. The wire AB can slide on a frame without friction and a uniform magnetic field passes vertically through the frame plane. When AB moves uniformly to the right, which of the following statement is correct? If resistance R is increasing, the pulling force can be increased. B. Higher speed requires smaller pulling force. Option C. Wire can maintain motion without external force. D. Wire is subjected to magnetic force. So here a wire is moving on a rectangular frame in the magnetic field. We know that as the wire moves, the flux, magnetic flux will also changes, and it will produce an induced EMF which causes the magnetic force. So here the pulling force is equal to B squared into L square into V divided by R, where B is magnetic field, L is length of the wire, V is velocity with which it is pulling, and R is the resistance of wire. So from option A, if R is increasing, so according to relation, R is inversely proportional to F, so force will decrease. So option A is incorrect. As V increases the velocity, the pulling force will also increase. So option B is wrong. Uh, Option C, here the wire can maintain the motion without external force. The wire cannot maintain the this motion without external force because there is also a backward pulling force due to the magnetic force, and this will deaccelerate the wire and eventually it stops the wire. So option D, accordingly the option D is correct because here the wire is subjected to magnetic force. Now we will move to our next question, that is question number 46. A uniform electric field is present in a horizontal direction on a horizontal desktop. A block of mass m is equal to 0.1 kg carrying a charge q is equal to 0.2 into 10 raised to power minus 24 coulomb is placed at a point 0 and released from rest. The sliding force between block and a desktop is friction force. F is equal to 0.2 Newton and block experiences an electric force is equal to F is equal to zero point 0.4 Newton. The net work done in 2 seconds is. Here the electric field is given in the diagram and the block is giving a charge of minus 2 into 10 raised to power minus 24 coulomb. So the electric force uh, is in minus x direction, and the friction force it will opposes this electric force. So the net force will become zero point 0.4 minus zero point 0.2, that is 0.2 Newton, and accordingly acceleration will be equal to zero point 0.2 divided by mass, that is given as 0.1 kg. So we will use second equation of motion, s is equal to ut plus half at square. Initial velocity is 0, so we will put the value of acceleration, that is 0.2 divided by 0.1 into time, that is 2. When we solve that this equation, then the distance covered by object will be 4 meter, and we know that work done is calculated by force into acceleration. So net force is 0.2 into distance, that is 4 meter. After solving this we will get 0.8 joule. So the answer is option C is correct. Now we will move to our last question, that is question number 47. In the scientific laboratory, three identical point charges are placed at a vertices A, B, C of equilateral triangle. Detector D is placed at the center and another at symmetric point F. Which is correct? Here the diagram is given, that is the three identical charges are placed at point A, B and C. So this, if we calculate the electric field at point D, the electric field due to point A and point C and point B, that is the net electric field at point D is 0. Okay, and the electric field if we calculate at point E and H, the electric field will be the same, that is not different. So option B is incorrect. So accordingly, if you see the diagram carefully, you will understand the problem. So option D is correct. Okay, thank you for watching this video. I hope you understand each and every problem. Please don't forget to subscribe this channel if you like the video. Thank you.